Hi, welcome back to my channel. Today we continue chapter 6, Light and Optic, on topic 6.6, Image Formation by Spherical Mirrors, part 1. Look at the diagram here. This is spherical mirror. And you look at this one is the inner surface of the spherical mirror. If the inner surface of the part that has been cut reflects light, the mirror is a concave mirror. So you can see this diagram A. This is the object. Light from the object hits the inner side, okay, and reflect. So this shape we call it concave mirror. If the outer surface of the part that has been cut reflects light, the mirror is convex mirror. So look at B here. This is the object. Light ray from the object hits the outer surface here, which is curved outwards, and the light ray reflect. So this shape we call it convex mirror. So you must be able to differentiate between these two types of mirror, concave mirror and convex mirror. Very simple example that you always use every day. There is a spoon. The concave surface and the convex surface of a steel spoon act as concave mirror and convex mirror respectively. So you can look at this one. For the concave shape, which is curved inwards, you can see your image is inverted. And then for the convex shape, which is a curve outwards, this one will produce image which is upright. So the characteristic you can observe from here is already show the difference between these two types of curved mirror, concave mirror and convex mirror. So we want to discuss more about the characteristic of image formed by these two types of mirror. Okay, before that we look at this one, fields of vision in front of plane mirror, concave mirror and convex mirror. For plane mirror, you have studied this one in lower form science. So I hope you still remember. Okay, look at this one. This is plane mirror. So the observer, when observed, like the object, the field of vision for the observer is this area. We call it narrow field of vision. If we use concave mirror, so you can see it produces very narrow field of vision. And if you use convex mirror, it will produce wide field of vision. So you must be able to relate this situation to what you discussed before about law of reflection. So angle of incidence equals to angle of reflection. So you can see this angle is same size. Okay, this angle is same size. Okay, so wide field of vision for convex mirror as compared to concave mirror and plane mirror. Okay, now let's look at the properties of concave mirror and convex mirror. This is concave mirror. As you can see, it curves inwards, the inner surface of a spherical mirror. Okay, so a line that passes through center of the mirror, P, this one we call it principal axis. Let's say parallel light rays travel towards the mirror parallel to the principal axis. What happened to the light rays? So this one apply concept of reflection. As you know that angle I always equals to angle R. So you can see this light ray hit the mirror at this point and bounce back or reflect. Look at this one, the green color also reflect. Okay, below part also same thing. Okay, reflect. So all the parallel light rays, as you can see here, once reflected, it will meet at one point here or converge to one point that we call it focal point of the convex or concave mirror. So this is the focal point of the concave mirror. So the light rays that parallel to the principal axis will be reflected and converge to F. So that's the reason why this concave mirror, we call it converging mirror. Now we look at convex mirror. The shape curve outwards. Okay, so this is a line that we call it principal axis. It passes through the pole of the mirror or center of the mirror. Parallel light rays incidence towards the convex mirror. This one also apply law of reflection. There is angle I equals to angle R. Okay, means you can just draw one tangent here and then draw normal line, so you will get I equals to R. So parallel light rays looks like diverge. If you try to extend all the light rays that diverge, it seems that it comes from one point behind the mirror. So that point, we call it focal point of the convex mirror. Okay, so for this convex mirror, the light rays that parallel to the principal axis will be reflected and diverge from F. That's the reason why we call it, this convex mirror is diverging mirror. Okay, now let's look at the symbol here. Okay, just now I have mentioned about P, the center of the mirror. F is the focal point. C actually is the center of the spherical sphere. Because this concave mirror actually one small part of a spherical mirror that we cut out. Okay, so this is the center of that sphere, and now it becomes center of curvature of the concave mirror here. Okay, so for concave mirror, you can see this focal point is real in front of the mirror, and the distance between F and P is focal length of the concave mirror, and the distance between center of curvature and the center of the mirror, we call it radius of curvature. The relationship between F and R is F is equals to radius divided by 2. So it seems like F is a midpoint of CP. Okay, so same thing for convex here. This is the pole or center of the convex mirror. This is the focal point of the convex mirror, and C is the center of curvature of the convex mirror. The distance between P and F is focal length of the convex mirror, and the distance between P and C is radius of curvature. So for this convex mirror, the focal point is virtual. It is behind the mirror. Okay, so that's the difference between concave and convex. So you must be able to identify the terms, or at least state the definition, the terms or the symbol that's stated here, like focal length, radius of curvature, center of curvature. Okay, so as mentioned earlier, for the concave mirror, F is real. For convex mirror, F is virtual. Okay, now for this topic, we want to draw a ray diagram in order to find the characteristic of the image form, or we want to find the position of the image form by curved mirror. Okay, let's discuss for the first one, concave mirror. So the guide to draw, or we call it a rule of drawing, there are 3 rules. The first rule is, this is the concave mirror. So as usual, you can draw a line that passes through center of the mirror. So this one will become the principal axis, and then use a ruler. You can set a scale. For example, PF you can choose 2 cm, and then FC 2 cm. It's like marking a scale for a graph paper. Okay, so it must be same length so that you can get an accurate position of the image. Okay, the first rule, light ray passing through center of curvature reflected back to its original path. Pass through center, meaning along the radius. If along the radius, meaning when hit here, it will hit at 90 degrees to the mirror or along the normal line. So the angle I equals to 0, thus angle R also 0. So it bounces back along the same path. Okay, pass through center. Okay, bounce back along the same path. Okay, that one is the first rule. Second rule, a light ray that parallel to the principal axis, it will be reflected pass through F. The third one, light ray that pass through F will be reflected parallel. So number 2 and 3 is the reverse direction of wave. So redirection of light. Okay, so when you draw a ray diagram, you just choose any two rays to draw a ray diagram. So in order to produce the characteristic of image, so for this rule, we can determine the characteristic of concave mirror, which the characteristic of image form is depends on the object distance. So we have 6 different object distance that will produce different characteristic of image. Let's say the first one, object at infinity. So object at infinity is light ray maybe coming from the sun, from the cloud, okay, which is very far. Okay, we can draw something like this, pass through center, okay, bounce back along the same path. And then you draw another light ray parallel to this line, pass through F, reflect parallel. So you can see these two rays will meet at this point, the reflected ray. So this is the position of the image and image form at F. So the characteristic of the image form is real, inverted, diminished at F. So it is real because we put a screen in front of the mirror. So don't get confused with the lenses. Lenses apply different concept, refraction. So we put the screen for lens is on the right side. For mirror, we put the screen on the left side. Okay, because this one apply reflection concept. Okay, so this is real, inverted, diminished at F, at focal point. Okay, next, U more than 2F. C is 2F actually. Okay, so here is more than 2F. So characteristic of image that form is real, inverted, diminished. You can see here parallel light rays reflect, pass through F, and then pass through F, reflect parallel and meet here. So this is a real, inverted, diminished. U equals to F, 2F, sorry. U equals to 2F meaning point C. Put exactly at C. So you will get same thing. You draw parallel light rays, reflect, pass through F, reflect parallel, and it will meet here also at C. So it produces a real, inverted, and same size image. Okay. Okay, next, U between F and 2F. Okay, parallel light rays reflect, pass through F, reflect parallel, meet here. So you compare between object and image. So image form in front of the mirror meaning real image. So real, inverted, magnified. Okay, and this one U equals to F. Put at F the object. Parallel light rays parallel to the principal axis, reflect, pass through F. Okay, from C, reflect along the same path. So you can see the light ray will never meet. It produces parallel light rays. So observers still can see the image. So the image form at infinity, we call it virtual upright magnified, because the image cannot form here. It forms somewhere very far that cannot be determined, very far. So it's virtual upright magnified at infinity. And then U less than F, close to the mirror. So same thing, you draw parallel light rays. Okay, reflect, pass through F. Directed from C. From C, it will be bounced back along the same path. And then you can see it also will never meet in front of the mirror. What you do, you extend to the back, you can see it will intercept here. So this is virtual image because formed in the mirror. So the size of the image is bigger, so we get virtual upright magnified. So there are 6 different position of the object, so you will get characteristic of the image form. So you must be able to sketch the ray diagram and to state the characteristic of the image based on the object distance. Okay, now for the convex mirror, there are 3 rules also. Okay, number 1, light ray traveling from C reflect back to its original path. Okay, towards C, directed towards C. So this is a virtual line. So it bounces back. Number 2, parallel to principal axis diverge from F. So this is also virtual line. So we draw broken line. And then part 3, okay, directed towards F. So this is virtual line. So it will be reflected parallel. So just choose 2 to draw ray diagram. So for your information, characteristic of image form does not depend on the object distance for convex mirror. For concave, yes, it depends on the object distance. But for convex, it does not depend on the object distance. Okay, we can draw. There are 2 different object distance. For example, U more than 2F. We just choose 2 rules. Parallel to principal axis, diverge from F. Directed towards C, bounce back along the same path. Of course, it will never meet here, so no real image. Extend to the back, the reflected ray, it meet here. So this is the image. So image is virtual, upright, diminish. If U closer to F, same thing. You draw parallel light ray, parallel to principal axis, diverge from F, directed towards C, reflect along the same path, extend to the back, meet here. So this is the image. So we get also the same characteristic of image, virtual, upright, diminish. So characteristic of the image remains the same for different values of object distance for convex mirror. So it's quite easy for you to memorize actually for convex mirror. So but I suggest you try to sketch the ray diagram so that you will understand better how to get the position of the image. So by using the ray diagram, you no need to memorize. You also will get virtual, upright, diminish characteristic of image.